Hello everyone. Good afternoon to all of you. Sorry I joined late this time. Okay. We'll start the session in a minute. Hello, yes. So in last class we have discussed paper. Okay. So today we will discuss about continuity and differentiability. Okay. So our main agenda is to complete as much as possible in 1 hour the syllabus of continuity and differentiability. Last class, I saw that mostly no one joined. So this is not, you shouldn't do that. Actually, you should attempt the paper and discuss it. If you will not discuss it, then there is no point of attempting the test, right? Because mock tests are there to evaluate, not only evaluate ourselves, but also check at which point we are. You try to motivate yourself. Okay, just hold on. This there are only 5 or 6 days is left. Okay, not only 5 days, actually 4 days are left. So please have patience. I know we have more anxiety this time, because as the exam coming day by day, we feel very tension, right? So take it, whatever is in your hand, take the responsibility of that. Okay, whatever is not, just leave it. Okay, so you don't have to worry about which is not in our hand. Clear? So with that, we'll start today's session, and please try to reattempt that paper. Try to discuss in the group also. If you have any doubt with any kind of question in the previous mock test, you can also. I'll give you my number. My number is this. Okay. You can note it down. And if you feel any doubt in the question paper, or if you feel that there is some concept, you can ask, feel freely, you can ask that doubt. Okay. Just put a screenshot of that question paper, or just tell me the question number. I'll dictate it to you. Okay. If yes, then please give it a thumbs up. Okay, very good. So now we'll start the class. So I hope you know some basics about continuity and differentiability. And as a student, I feel when I was also in 11th and 12th, I felt that limit LCD part is very much easy compared to other chapters in class 12. Right? If you feel the same, then again put a thumbs up. And if not, then tell me, we'll discuss the theory part also. Okay. Yes or no? Do you feel the same, that continuity and differentiability along with limit is very much comfortable chapters rather than other chapters in class 12? No answer. Why? Okay. No, no problem. We'll discuss some of the questions. See, what I know, that continuity, when we start continuity suddenly strike in our mind that continuity means continuous. There is no break. Draw a graph or anything. If I do not lift my pen while drawing it, then that, what does that mean? That means is the graph is continuous. Let's say let's say this is my coordinate, okay, and I am drawing deliberately a graph, okay, randomly, it's on my wish, okay, so I am drawing like this. Did I lift my pen while drawing this graph? Tell me yes or no. Did I lift my pen while drawing this completely from this point to this point? No. Yes. How? When I lift, while I was drawing from this point, let's say this point is point A, and this point is point B, then when I lift the pen from A to B, did I lift it? No, I did not lift it. If you did not understood, yes, clear? We didn't lift the pen. That means we have made a smooth curve. Okay, so there are three kinds of drawing we can do, and according to that we can say whether a function is continuous or not. Okay, so clearly this function is continuous or this graph is continuous. Okay, why? Because I did not lift the pen. But there might be some cases when I can lift the pen, but the curve may not be that much smooth. Okay, so with that we'll start our session. So in this session we'll talk about graphical approach. We have learned so many methods in continuity and differentiability, how to check whether a function is continuous or not. I think you know basic understanding of continuity. We'll also discuss this, but first let's discuss the graphical approach. So there are three kind of graphs I have made. First, you can see first graph is smooth as well as continuous. Here you can see we have drawn like this. Okay, so we did not lift the pen and we did not actually make any sudden changes, right? So the graph was smooth and actually we did not lift the pen, so graph is again continuous, right? No issue. Second case, here you can see when I'm drawing it from left hand side like this, now I suddenly change the direction of the graph. Okay, so here you can see a turn sharp turn. Whenever you see a sharp turn, first of all we should check whether this function is continuous or not. So continuous means you should not lift the pen in the whole part when you are drawn the graph. So clearly we can see we did not lift the pen. That means the graph is continuous, but the graph is not smooth. Why? Because we made a sharp turn. Clear? In this case we did not made a sharp turn. Sharp turn would be, if in this case if I try to deliberately move a sharp turn, then that sharp turn would be this. Clear? So this would be a sharp turn in the first case. Did you get it? Please let me know. If you get it, please let me know. Good. Okay, so in this case the graph is smooth as well as continuous, but in this case graph is smooth, graph is not smooth but continuous. Why? Because we are making a sharp turn. Clear? Drawing any curve, then the break we get, that shows us discontinuity. So here you can see I have drawn a graph. So what I have started from here. I have made a line, then I have lifted the pen. So now you can see there is a gap. Okay, and then I have again made a line or a curve, then I again lift it and made a line, then again lift it and again lift it. Okay, so I how many times I have lifted the pen? 1, 2, 3 and 4 times I have lifted the pen and completed the graph, right? So clearly if I make at least one lift during the drawing of the graph, that means the graph is clearly discontinuous. So you can see the graph is discontinuous. And how many discontinuous points are there? 4 points of discontinuity. 4 points of discontinuity. Is it clear? Because 4 times I have lift the pen while drawing the complete graph. Please let me know if it is clear or not. I have unmuted you. You can also tell me by unmuting yourself yes or no. Okay. So there is no issue. But at the time of whenever I am teaching you, you should unmute yourself. Okay. Is it clear? So you can discuss with me as well. If it is yes, you can say yes or no. Okay. So now we'll move on to the problem part. So here, what we do, we'll solve the questions using the graphs. So I hope you have basic idea about graphs. If not, we will discuss that also. Okay, so first question, I hope in the screen you can see the question. Okay, so we'll start. First of all, we'll read it, and you guys can also try to solve it. Okay. Meanwhile, if you have any problem, you can refer the notes. Okay. So in the question number 1, what is it is saying that let S be the set of points where the function fx is equals to this. So I'll write it down here separately. Fx is given mod of 2 minus, then again mod of x minus 3, mod close, mod close. This is our function, and here x can be take any real value. So x is belongs to R. Okay, and S is the set of point where the function is not differentiable. Not differentiable. So what does that mean? Differentiability we have learned. Continuity along with differentiability. So what differentiable means? A function can be differentiable if it should be continuous. Then we can talk about its differentiability, right? Right or not? And if the function is not even continuous, then clearly at that particular point the function will not be differentiable. If it is acceptable to you, then please let me know. If you know this part, then please let me know. If the function is continuous, then we can talk about its differentiability. Maybe it can be differentiable or not. But if it is not continuous at some point, then clearly that point the function will not be differentiable. So what the meaning of this? Meaning of this means if a function has sharp term, if the function has sharp term, that means the function is continuous, but the function is not differentiable, because we have learned that whenever we get sharp term, that means it is not differentiable, not differentiable. Or whenever the function is discontinuous, clearly at those points the function is again not differentiable. Yes, not smooth, or the we can lift the pen. That at that point also the function is not differentiable. So here at 4 points means -1, 0, 1, and 2. The functions are again not differentiable. Discontinuity implies means not differentiable. And continuous means may be differentiable or may not be. May be differentiable or may not. Clear? So in this case, we are getting x is equals to 0. We'll be getting function is not differentiable. But here in this case, the function is smooth as well as continuous. That means the function is differentiable for all x belongs to graph. Means you can say domain of the function. Okay, for all x belongs to domain of the function. Here function is not differentiable at x is equals to 0 in this graph. Clear? Shall we go ahead? So graphical approach. So what we do, one by one, we will draw the graph of the inside function, and then we are going to make a function fx. So initially we can see this complete internal function is modulus of x minus 3. And when we see modulus, we remember mod of x, right? If you know, then please let me know. What is the graph of mod of x? Sir, this graph. Victory sign, right? Victory sign graph. So we'll start with victory sign graph. So victory sign graph is this graph. This graph is our modulus x function. So we say this is y is equals to mod x. Clear? Now we have to move from mod x to mod of x minus 3. So now we will draw from mod x to mod x minus 3. So if you remember, from fx to f of x minus k, if we draw a graph from fx to f of x minus k, then what does that mean? How we will draw the graph if we know the graph of fx? We will shift, we will translate or shift horizontally by k units. And which side, left side or right side? Sir, it depends on k, whether it is positive or negative. Here in this case, you can see k is equal to 3. So k is positive. That means we have to move to the right side, to the right side. And if k is negative, then we have to move to the left side. I hope this is clear. Okay, so what we have to do? We have to move 3 units to the right side horizontally. So for x is equals to modulus of x minus 3, here we will shift by 3 units. So horizontally to the right side. So you can see this point is 0 actually. This is 0. So what will happen after shifting 3 units? The sharp point, this is a sharp point. This will come here at x is equals to 3. So we will draw the same graph, but a translating of 3 units. So this will be my graph of y is equals to modulus of x minus 3. Clear? Any doubt till here? Now we have to draw the graph of minus of mod x minus 3, because there is minus sign. So what we will do, we will convert from fx, here fx now is treating as mod of x minus 3, to minus fx. And when we talk about minus sign of some function, then what we do, we take a reflection over the x-axis. Okay, so here what we do, we'll take the complete image or reflection of this function modulus of x minus 3 over this axis. This is my x-axis. Clear? So now in this case, I'll draw it with some other color. So let's say this. Is modulus of minus times modulus of y is equals to minus times modulus of x minus 3. Clear? Now what we have to do, we have to add 2. Okay, so by adding 2 means now fx, we are treating fx to k plus fx. Here k is 2. Clear? So what does that mean? We have to move upward. K is to positive number, so we have to move vertically upward by 2 units. So we have to shift this graph 2 units above. Now you can see the maximum value of this graph is 0. So after shifting by 2 units, the maximum value will be 2. So what will be the graph of This function now I'll draw separately. Okay, so the new function will be look like this. Okay, so now what is that point? I'll use some other color. Okay, so that point is 2. Clear? Because we have moved 2 units. Now we have to find these points. Okay, so this function is actually y is equals to 2 minus modulus of 3, modulus of x minus 3. Okay, so what we have to do, we have to find this point. This point means we have to find x-intercept. X-intercept means y is equals to 0. So we'll put y is equals to 0, or we can check at which value this value is completely 0. So let's say if I put x is equals to 3, we'll be getting 2. So why don't we should put x is equals to 5? So at x is equals to 5, 5 minus 3 is 2. 2 minus 2 is 0. So this is 5. And similarly, in this way, I can also put x is equals to 1. So 1 minus 3 minus 2, but modulus is there. So 2, 2 minus 2 is 0. So this is 1. Clear? So we have gone through this graph. Now finally I have to take modulus. So again, by taking modulus, modulus means we have to take image of below the x-axis part with respect to x-axis. Means all things are positive. Modulus means all are positive. So whatever the graph below the x-axis, we have to take reflection of it with respect to x-axis. So what we will do, we will now take the reflection of this part over this axis, x-axis. Clear? So this is the reflection and this one is the reflection. Clear? So this finally this graph, finally this is the required graph, or this is the graph of fx. I have shaded it so that you can understand clearly. Clear? So next page, what we will do, or let's say in previous page, we have what we not differentiable. So this is my fx graph. So we have to check whether it is smooth or not. So clearly this graph is not smooth because we have made sharp turns here at x is equals to 1 and at this point. Okay, so we have to check this point when the value of this function is 2. So what we will do, we will put is equals to 2. Okay, so here I'll solve it. 2 is equals to 2 minus modulus of x minus 3. So if you solve it, you will get x is equals to 3. Yeah, so at this value is x is equals to 3. So here also we are getting sharp turn, and at x is equals to 5 we are also getting sharp turn. So this function is continuous, no doubt, because we did not lift the pen, but we are getting 3 sharp points. That means at those points of x we will be getting function non-differentiable. Clear? So what will be the set s? Set s is the point where we are getting 1, 3 and 5, where we will be getting non-differentiable function. Clear? Now we have to find of fx, means composite function. Okay, for function for all x belongs to set s, means we have to find at x is equals to 1, at x is equals to 3, and at x is equals to 5. Okay, so I'll solve here. So sigma of f of fx for x belongs to s, means we have to find out for f of f1, then use sigma, then f of f3 plus f of f5. Clear? So now we have to check what is the value of f of 1. First of all, we'll find f of 1, then whatever value is coming out here, we'll find f of that value. Okay, so previously you can see what is f of 1. This is function, f of 1 is 0. Clear? So we'll write f of 0 plus f of 3. f of 3 is 2. So we will write f of 2. Clear? Because we have substitute f3 as 2. So outside there is one f also. So f of 2 plus f of 5. F of 5 is there. F of 5 is again 0. Y value is 0. So we'll write f of 0. Now we'll check what is the value of f of 0 and f of 2. Clear? So now f of 0 is means we have to put x is equals to 0. Put x is equals to 0 here. So we'll get 2 minus modulus of minus 3. Modulus of minus 3 is 3. So 2 minus 3 is minus 1. Okay, sorry, my bad. There is modulus also, na? Because we have to draw this complete graph. Complete graph is this one. So 2 minus 3, sorry, x is equals to 0, we'll be getting here 3. 2 minus 3 is minus 1. Again mod means 1. So clearly we can see this is 1. Positive value is coming. And f of 2 we also have to found. So put x is equals to 2. 2 minus 3 is minus 1. Minus 1 modulus is 1. 2 minus 1 is 1. 1 modulus is 1. So we are getting f of 0 1, f of 2 1, and f of 0 again is 1. So finally answer is 3. Now we have to check which option is correct. Okay, there is no option. So 3 is my answer. Clear? Understood? Basic thing, we have to remember the transformation of graph. We have learned function, or we have learned the transformation in class 11. So we are using basic graphs. Understood? There is no problem. Okay, so we'll move ahead with the next question. Next question is this. Okay, so the function is defined on -3 to 3 close interval, and we the function is given. So piecewise function is given because at some values of x there is some definition of function, and for some other values of x there is some other definition of function, and where bracket of x denotes the GIF function. Clear? Then we have to find the number of points where the function is not differentiable in open interval -3 to 3. Okay, open interval -3 to 3. Okay, so sir, what we should do? First of all, we should draw the graph. Okay, so here what we will do, first of all, let me just, okay, so the function is from -2 to 3 completely we have to draw, na? So I'll draw like this. Now okay, so first of all we'll draw for -2 to 2. So -2 is, let's say, somewhat here. And here it is 2. So in this value, in between -2 to 2, we have to think the function is this. So we have to find the minimum of these two functions. So what we have to do, first of all, we should draw both the graphs and check which function is minimum. Okay, so first function is modulus of x. Modulus of x means victory sign graph. So we'll draw modulus of x. So this is 0 to 2 and this is -2 to 0. Clear? This is modulus x. And next graph is 2 minus x square. Okay, so one by one we'll draw it. First of all, if there is only x square, then we'll draw like this. Clear? Then minus x square means taking reflection with respect to x-axis, minus x square. Then we have to add 2. So adding 2 means shifting vertically 2 units. So graph will be 2 minus x square. So minus x square to 2. So you can see this is maximum value is 2 here. For modulus x, this value is 2, because x is equals to 2 we'll be getting 2 and -2 also we'll be getting 2. Now 2 minus x square. So 2 minus x square will be like this. Yes or no? We are shifting minus x square graph 2 units above. Okay, so maximum value was 0 for minus x square. So adding 2 will be maximum value 2. Okay, now check at x is equals to minus 2, what will be the value? So for 2 minus x square at x is equals to minus 2 or plus 2, we'll be getting same. So 2 minus 4 is minus 2. So here we'll be getting at both values of 2 and minus 2, we are getting minus 2. Clear? We can also find these points, but whenever we need, we'll try to find it out. Now we have to find out the minimum value. Minimum value means whatever the graph is below, which will is the minimum. Okay, so minimum graph. Okay, so in these two sections, what is the minimum graph? Minimum graph is the red one. So this one. Then here minimum graph is green color graph. Again minimum graph is green color graph, and here red color graph is the minimum graph. So this is my required function for x belongs to minus 2 to 2. This part is clear. Now again we have to draw the function for belongs to belongs to open 2 to close 3, because 3 we can see equal sign. Then the function is bracket part of modulus x. Modulus x का bracket लेना है. Clear? So first of all we have to check which values of x function is defined, because here it is modulus of x. Modulus of x is there means for negative values of x also in the same interval this function is defined. That means अगर इसकी वैल्यू 2 से 3 में है तो -3 से -2 में भी होगी, -3 से -2 में भी होगी, -2 पे ओपन, यूनियन पॉजिटिव वैल्यू पे भी होगी, मींस open 2 to close 3. So this is -2, this is 2, x is equals to, now we have to draw here -3 and here 3. Clear? So from -3 to -2 here we have to draw the graph, and 2 to 3 we have to draw the graph. अब ग्राफ क्या है? What is the graph? Graph is GIF of modulus of x. Okay, so first of all we'll talk about in this interval. So in this interval x is positive. X is positive means modulus x has no point to be introduced. So here the value will lie in between 2 to 3. What is the GIF of any value between 2 to 3? Okay, any value between 2 to 3, let's say 2.5. So GIF of 2.5 is 2. So it means the value of this function in this interval will be 2. So 2 is not taken. So here we'll put open, then the value is 2. Now at x is equals to 3, what is the GIF? GIF of 3 is 3. So here we should put here again hollow circle, and at x is equals to 3 we'll be getting exactly 3. So this is 3. Clear? Same case we'll be talking about in -3 to -2. So in -3 to -2, what will be the modulus? Modulus value will again be from 2 to 3, because positive we are taking. So again any value between 2 to 3, what is the GIF? Again 2. So here again open circle, because -2 is not taken, and till -3 open the value will be 2, and at x is equals to -3, what is the modulus? 3. What is the GIF then? 3. Okay, so this is the complete graph. So blue graph is my complete graph of this function fx. Clear? Now we have to talk about the number of points where function is not differentiable in open -3 to 3. It means we do not consider this point and we do not consider this point also. So we had to check from open minus 3 to 3 how many discontinuous points or sharp turns are there. So first is this point, means x is equals to minus 2. Second point is this point. There is, you can see a sharp turn. Here you can see there is pen lifted, right? Here again sharp turn. Here again sharp turn. And at the last we are getting here hollow circle, means function is discontinuous. So again function is discontinuous means not differentiable. So how many sharp points we are getting, or how many non-differentiable point we are getting? So non-differentiable points are 5. 1, 2, 3, 4 and 5. Clear? So answer will be 5. If in the examination if it would be asked that what is the number of differentiable points in close minus 3 to 3, then we have to take care of these points, right? Because at minus 3 there is gap, there is pen lifted, and again at 3 point pen is lifted. So in that case the number of non-differentiable point would be 7. But here in the examination, in this question, examiner asked for non-differentiable points in minus 3 to 3 open. Okay, so this was a very good question. Clear? So with the graph we don't have to write it so much long. Yes or no? Okay, so next question is, let f from R to R. Okay, f is defined from real number to real number, and f is again piecewise function. F is defined in these intervals. Okay, now gf is also gx function is also defined from R to R, and gx is given this function. Okay, so first of all what we'll do, we'll try to draw the graph of fx. Okay, so here than or equal to 2. That means what? That means x should be belongs to minus 2 to 2 open, 2 close. Clear? Because at 2 there is equal sign, right or not? And in this case what will be the range of x? X will be minus infinity to minus 2 open union 2 to infinity. Clear? This part is clear. I hope this part is clear to you. Okay, now we will draw the graph first of all from minus 2 to 2. So let's say this point is minus 2 and this point is 2. So in this interval we have to think this graph as this function. Okay, the good thing is from minus infinity to minus 2 union 2 to infinity means in this interval, and in this interval the value of function is 0. So this will be my function. At minus 2 it is open, so I'll put hollow circle. Again at 2 it is open, so I'll put hollow circle, and after 2 the function value is 0. Clear? Now modulus of x, 3 times 1 minus modulus of x by 2. So first of all think about it, what is modulus of x? Victory sign. So graph will be look like this. Then we have to divide it by 2. So if we'll divide any function by 2, what will happen? The slope will go either upward or downward, right? Function value will be either less or either more. So clearly you can see there is a division by 2 means the value will decrease. So value will decrease means slope will be lesser. So I'll just draw it and then I'll remove it. So the if you check for x is equals to 2, what we will be getting? 2 by 2 1. So we'll be getting something like this, right? This value is 1. Clear? Right or not? So this is the function of modulus of x by 2. Then what we have to do, we have to take minus sign, means reflection. Reflection means the graph will now look like this. This is y is equals to minus modulus of x by 2. This was y is equals to modulus of x by 2. Now what we have to do, we have to add 1. Add 1 means lifting upward by 1 unit. So this value is 0. If I lift it, all values will be moved 1 unit upward. So at this point, x is equals to 0, y is 0. Now y will be 1. So here, and this value is 1. This value is minus 1. So minus 1, if I move upward by 1 unit, these value will be at 0. So the function will look like this. Right or not? This will be my net function. Now I have to multiply it with 3. Multiply it with 3. 3 is a positive number. So what will happen? The y range will increase by range will be multiplied by 3. So all values of y will be multiplied by 3. What does that mean? At here at x equals to 0, we were getting 1. But while multiplying with 3, this value will goes to 3. Right or not? And here at x is equals to minus 2 and 2, what is the value of the function? 0. So here again 0 into 3 is 0. So the function will look like this function, right? This. So what I'll do, I'll remove all these parts which I have told you so that you can understand. Okay, so now this is my coordinates, and this is x is equals to minus 2, where we were getting open circle, and at x equals to 0 we were getting open circle, and the graph is now from 0 to 3 and 3 to 0. So that means is now we can fill these hollow circles, right? Because for this function we were also getting 0 at x equals to minus 2, and for this function we were also getting 0, right? So we can fill. So this is the complete graph of fx, right? This is the graph of y is equals to fx. Now we have to find out the graph of gx, and what it is saying that gx is f of minus f of x minus 2, and let n and m be denote the number of points in R where g is not continuous and not differentiable respectively. Means n is the number of points where function is not continuous, so discontinuous points. And what is m? M is number of non-differentiable points. Clear? So first of all, we'll find out whether the function is lifted or not. Okay, so for that, first of all, we need to find out what is gx graph. Okay, so we have already made f of x graph. Can we make a graph of f of x plus 2? And also, can we make a graph of f of x minus 2? Yes, we can make. We have used earlier here. Okay, f of x plus a, f of x minus a, k. So here for x is equals to f of x plus 2 means we'll move horizontally towards left side, okay, backward side of x-axis by 2 units, right? So this complete graph will be shifted by 2 units. Okay, so I'll use red color again so that it is clearly visible to you. I'll draw the coordinates by green color and then I'll use red color. So now if I'll shift this complete graph by 2 units backward direction, this point will goes to -4 and this point will goes to 0, right? Because we are shifting 2 units. So the graph will look like this. This point is now -4. This point is -4. Then there is some triangle you can see. So this graph, right? And this is ending at x is equals to 0 because 2 will be shifted 2 units left and we'll restart the same thing. So this is my complete graph. This is x is equals to 0. This is 3 we were getting initially, right? Okay, so what is this? This is the graph of y is equals to, or I should write here, y is equals to f of x plus 2. Now what we will do, we will draw the graph of minus of f of x minus 2. Means first we will draw f of x minus 2, then we'll take reflection with respect to x-axis. Okay, so f of x minus 2 means now fx will be moved towards positive x-axis by 2 units horizontally, right? So what will be the graph? I'll use now yellow color. So this point will move to 0 and this point will move to 4. Okay, so the graph from till 0 from left hand side it will be 0. So the same graph I'll be using here, 0. Then there is a triangle type. Okay, and then again it is 0. So this is x is equals to 4. This is again 0. Clear? This value is again 3. So this, what is the graph? What is the function? This is f of x minus 2. But we had to take minus also, means taking the reflection with respect to x-axis of this function. So what will happen? So this is again the same thing we will be getting yellow. Then reflection is this, and then we'll be getting yellow. So now the complete graph I'll use different color to show you that what is we are getting. This is my complete graph. This is my, I am drawing for fx for f of x plus 2. So this is my f of x plus 2. Okay, and green I'll use. Green I'll use for minus of fx minus 2. This is minus f x minus 2. So here this is minus of f of x minus 2 graph. So I'll shade it with green color to understand better. Okay, we have to add these two graphs, clear, to get gx. So what will happen? Here you can see in this side there are both colors, means the function value is 0. 0 plus 0, right? 0 plus 0. So till -4 the net graph is 0. Clear? I'll use different page. Okay, so till x is equals to -4, we were getting gx as 0 because both graphs were there. Now, after x is equals to -4, we were getting this is f of x plus 2, but what is minus of fx minus 2 is 0 again. So it means we are adding 0 to this graph. So the net graph will be this graph. Clear? So the net graph will be this graph. Clear? This is 0. This value is 3. Now, after this, what is f of x plus 2 here? Here it is 0. So this value is 0. 0 plus this graph. This graph is below graph. So below triangle we will draw because 0 plus something is that value. So here we will draw below triangle. This value is 4. This value is -3. Here. Now after 4, what is the blue graph? Blue graph is 0. Means first function is 0. 0 plus. What is the next graph? Green graph. Green graph is also 0. So 0 plus 0 is 0. Means after 4, the complete graph is 0. So this is my required graph. This is the graph of y is equals to gx. Right? And now you have to find out number of discontinuous point, which is denoted by n, and number of non-differentiable point, which is denoted by m. So clearly the graph is continuous. There is no discontinuity. So n is 0. What is the number of non-differentiable function? Means either the graph is discontinuous or the graph has sharp turns. So you can see there are 4 sharp turns. Right? So m will be 4, and we have to find out what? We have to find out the value of n plus m. N plus m will be 4. Clear? I hope this part is also clear to you. So we'll move ahead. You can also cross check if there is any doubt, and you can ask. So with the graphical approach, we can easily solve the graphs. Actually, I am taking time because I am dictating it to you each and every step, right? That's why it is taking time. But for you, it will be like quickly. Okay. Now we'll move on to the next question. Okay, so here in this question, what it is saying that let a function g defined from 0 to 4 to r. Okay, so this is my domain and this is codomain, and the function gx is defined this. Okay, so here it is given that maximum of this function. We have done this kind of questions in the regular classes. So what we'll do, first of all, we'll draw, this is simple graph. So we'll draw this graph in 3 to 4. So this is my coordinates from 3 to 4. Okay. So this is 3, this is 4. On 4 it is close, on 3 it is non-close. So if I go to x is equals to 3, this is linear graph. X is equals to 3, we are getting 1. Okay, and x is equals to 4, we are getting 0. So graph will be like this. This is 1. Okay, at here we'll put hollow circle because 3 is not taken. Now for x is belongs to 0 to 3. This is 0 and 3. So in this interval we have to draw this graph. Now what we will do, we will separate it. Okay, मतलब इतना difficult graph तो हमें draw करने में time लगेगा. So what we will do, I'm writing this as, assuming this function as h of t. Okay, this function is h of t. So h of t is t cube minus 6t square plus 9t. So what I'm taking, I'm only taking this value, then I'll put -3. Means I'll shift the graph, whole graph by 3 units horizontally downward. Clear? Why I am taking? Because this is very easy graph. Easy graph. Why? I can take t common. So t square minus 60 plus 9, which is clearly a perfect square. So you can write t minus 3 whole square. So now you can see this graph is having three x-intercept or three roots or three zeros. One is x is t is equals to 0, and here it is getting t is equals to 3. So what will happen? The graph will intersect at x is equals to 3, but the graph will touch at t is equals to 3. Right? Because at 3 we are getting repeated roots, and when we get repeated roots, the graph will touch that point. Okay, so if I draw only this graph, what will happen? Okay, so this is my t0, this is my t is equals to 3. So graph. Now at x tending to minus infinity, clearly this is dominating term. So from minus infinity, we'll start like this, and then we'll cut at x is equals to 0. Okay, then at x is equals to 3, we have to touch. So the graph will look like this. I'll take 3 here. Okay, clear or not? So this is the graph of h of t, but we have to draw h of t minus 3, means shifting this whole graph 3 units downward. So first of all, we should find out what is this maximum local maximum value. So you can see how you will find out maxima minima. You will differentiate the function. So h dash t we'll write 3t square minus 12t plus 9. We'll put it equal to 0. 3 is common. T square minus 4t plus 3 is equals to 0. So clearly the roots are t is equals to 1 and 3. So at 3 we are getting this 0 at 1. So this will be the one value where we'll be getting maximum value. And we can also find the maximum value by putting t is equals to 1 in this graph. Right? So t is equals to 1. 1 minus 6 minus 5 plus 9. 4. Now we have to shift this graph 3 units downward, because this is not the complete graph. This is the complete graph. So what will happen? Thus, this local maximum value will goes down to 1, because we have to make it 3 units vertically downward. Okay, so the graph and this point will goes to minus 3. So graph will be something look like this. See, again this is 3, so sorry, this is 0, y value is 0, again minus 3 will be there. So this will be somewhat like the graph. Clear? This graph is, let's say this graph is p of t. Okay, so this is p of t graph. This is what? This is h of t graph. Clear? So p of t we have to draw, but what we have to think, we have to find out the maximum value when the value of t is lying from 0 to x. 0 to x. X is variable, but x. So let's say just think any value which lies between 0 to 3. Let's say 2. Okay, so what will happen at x is equals to 2? So for this graph I am talking about p of t. Okay, at x is equals to 2 is somewhat here in this region. Let's say this is my x is equals to 2. Okay, so we are getting this value. So what we have to do, from t is belongs to 0 to 2, we have to find the maximum value of this function. So 0 to 2, we have to find maximum. What is the maximum here we are getting? This is the curve from 0 to 2. So maximum value is 1. Right? So what will happen? We have to find the maximum whenever in this region till 0 to x. So 0 to x, x maximum is 3. So till 0 to 3, we have to find maximum graph of this function. So we need only this much graph. I'll this much graph. 0 to 3 we need only, right? And we have to find the maximum of this graph in this interval. So if there is till x is equals to 1, if I'll take any value between 0 to 1, what will be the happen? What will happen? The graph, the value, maximum value will be at that point only. Let's say I'll take x is equal to 1 by 4. So 1 by 4 पे वैल्यू क्या होगी? यहाँ कहीं होगी. तो 0 से 1 by 4 में मैक्सिमम वैल्यू क्या होगी? 1 by 4 पे जो वैल्यू आएगी वही होगी, है ना? इसका मतलब क्या है? If I move from 0 to 1, the maximum value will be the graph of PT, because that value will increase. So maximum value will increase. So from 0 to 1, the graph will be from -3 to because maximum value is 1. Okay, after 1 to 3, what is the maximum value of this function? This function is 1, because whatever value you will take, it will say that this graph, let's say if I'll take x is equals to 2, so for this graph, what is the maximum value? 1. So every time from 1 to 3 we are getting 1. Clear or not? So this is the final graph we are getting. Here it is -3, and we are getting till 1, and then from 1 to 3 every value is 1. Clear? Now you will see that here what is happening while moving this, the graph is tangent is tending to 0. See, tangent is parallel to x-axis, means tangent is 0 at this point. Okay, so the graph is actually a smooth curve. This is smooth curve, because this is also horizontal line, and at this point tending to 1, the tangent will be also parallel to x-axis. So that means its slope is 0. So it is horizontal, right? So now we have to find out, this is our final curve of y is equals to gx. So now we have to find the number of points in the interval 0 to 4. 0 to 4. Gx is non-differentiable. Non-differentiable means either not continuous or having sharp turn. So from here we are getting smooth curve. Now we are getting discontinuous points. So this is one point where function is non-differentiable. Again we are getting smooth curve. So how many points? Only 1 point. Clear? Any doubt? Got it? I know this was slightly difficult, but we have learned this kind of questions. Okay, so next part is use of LHD and RHD. Okay, so here we know the basic definition of continuous function. If we have to check whether a function is continuous or not at any particular point, what we do at that point, we find LHL, means left hand limit, we find RHL, right hand limit, and also we find the function value. If all the values are same as well as finite, then we say that the function is continuous at that particular point. So I'll dictate to you with graph also. So let's say the function is something like this. Okay, so let's say we are talking for x is equals to a. Some point is there, a point. Now you will see, and this value we are getting somewhat around L. Okay, so if we are moving from left hand side to this particular point A, means any value which is slightly lesser than A. So what does that mean? Left hand limit. If that value is a finite value, let's say we are getting L, approximate we are getting L. Again, we'll check from right hand side. So from right hand side, if you will go to that point slightly nearer to x is equals to a, then this is the point. Again, we are getting this value is approximately the same. And at that point A, the function value should be the same. That means that graph is smooth, right? So here the function value as well as the value at right from the right side and the left side all are same and finite. Then we can say that the function is continuous at x is equals to 0. If let's say we would be getting at x is equals to wait some other value. Let's say we are getting not L, we are getting some value, let's say M. M can be either above L or below L. Okay, then what will happen? The function will not be continuous because we have to lift the pen, then we have to mark here. So the function will not be continuous at that case, right or not? Clear? So also we have to check that the value which we are talking about should be in the domain of the function. It should not be like that at that point of value the function is not defined. It should not be that. Here the function value should also be defined at that particular point if at which we are talking about continuity. ओके सो डिफरेंशिएबिलिटी में हम क्या करते थे? डिफरेंशिएबिलिटी में हम एलएचडी और आरएचडी लेफ्ट हैंड डेरिवेटिव एंड राइट हैंड डेरिवेटिव की बात करते थे, राइट? इस पे हम एक क्वेश्चन सॉल्व करते हैं. सो क्वेश्चन इज सेइंग दैट find the if the function is given fx is equals to this much, then we have to find the value of, okay, so what is given? Okay, this function is continuous. It is saying continuous at x is equals to 0. Continuous at x is equals to 0. What does that mean? At x is equals to 0 and from the left hand side as well as from the right hand side, all the values should be is equals to some finite quantity, right? That means limit at x tending to 0 minus f of x, which is LHL. What is RHL? RHL means limit x tending to 0 plus of fx and function value f of 0, all r should be same. Clear or not? Then we can say the function is continuous at x is equals to 0. So one by one we will find out the LHL and RHL and f of 0. F of 0 is clearly given k. Okay, so we have to only think about these values. So first of all we'll find LHL. LHL means limit x tending to 0 minus f of x. So which function we have to check? We have to use x tending to 0 minus means negative value. Negative value function is only defined here. So this function we have to take. So limit x tending to 0 minus 1 by x ln of, because base is e. Okay, this is something upon something, right? M by n. So I can use log property. So I'm writing log m minus log n. So ln 1 plus x upon a minus ln of 1 minus x upon b. क्लियर? इतनी बात तो क्लियर है. और इसको डिनोमिनेटर में ऐसा करते हैं, we'll write that x in the complete denominator of x. Now what I'll do at x equals to 0, at x tending to 0 minus, first we will check what we are getting. So if we put x is equals to 0, ln 1 0 minus ln 1 0, so 0 by 0, right? So we can use LH rule, right? Or what we can do, we can, okay, simply we'll write LH rule. Now LH rule is slightly easy. So first of all we'll segregate this x to both, okay, and then we'll use LH rule, means differentiation of this upon differentiation of denominator. So what is the differentiation of ln? 1 by something, so 1 upon 1 plus x upon a, right, into differentiation of that function, means chain rule. So differentiation of 1 is 0, differentiation of x by a is 1 by a. Okay, upon differentiation of x, 1 minus, same case here, differentiation of this function. So 1 upon 1 minus x upon b into chain rule, differentiation of inside function. So here we'll be getting minus 1 by b into 1 upon differentiation of denominator, whole limit tending to 0 minus. Okay, so in the next page, what we can write, we will write LHL is equals to limit x tending to 0 minus. Now we will substitute x is equals to 0. So here we'll get 1. This is 1 by a. So completely this value is 1 by a. Here also, if I put x is equals to 0 minus, then this is 0. So we are getting 1 minus 1 by b and with a minus. So this will be plus 1 by b. So we are ultimately getting 1 by a plus 1 by b. Clear? Now, RHL also we have to solve. RHL is limit x tending to 0 plus fx. Fx means function defined for x greater than 0. So this function we will be taking. So we'll be writing cos square x minus sin square x, then minus 1 upon under root x square plus 1 minus 1. Okay, again we'll check at x is equals to 0 plus what we are getting. So 0 cos 0 1, 1 minus 1 cancelled, sine 0 is 0 upon 1 minus 1. So 0 by 0 form is again getting. So either we can use LH rule or we can use simplification method or rationalization method, because in the denominator you can see some rational term is there. So first of all, what we should do, ethically we should use rationalization. So first of all, you can also simplify this cos square minus sine square, cos 2 theta minus 1 upon root x square plus 1 minus 1 into conjugate or rationalization of this. So root over x square plus 1 upon root over x square plus 1 plus 1. Clear? Now we can write limit x tending to 0 plus. Okay, 1 minus, you can write minus times of 1 minus cos 2x. I have taken minus common. In the denominator, a square minus x square plus 1 minus 1. 1 cancelled, only x square is remaining. And here it is, we'll write this as it is. Okay, now what we have to do, we have to first of all check which at x tending to 0 plus which value is there any value which is finite or not. Okay, so basically we have to put it. So 0, if we will put 0, cos 0 is 1, 0 upon 0. And what is this? 0. 0 plus 1 is 1. Under root of 1 is 1. 1 plus 1, 2. So I can take 2 outside. And I can write 1 minus cos 2x upon x square. And this is the basic limit which we have learned. 1 minus cos 2 theta upon theta square. What is the value? Minus 2. Sorry, 2. So we'll be getting, or you can use LH rule also. So let's say using LH rule, because 0 by 0 form is there. So minus 2 into 2 sine 2x upon 2x, limit x tending to 0 plus. Now you can see sine 2x upon 2x. This is basic limit. So at limit x tending to 0 plus, we'll be getting 1. So this we are getting minus 2 into 2, which means minus 4. So finally we got the values. We are getting LHL is equals to 1 upon a plus 1 upon b, and it should be is equals to RHL. So RHL means minus 4, and it should be equals to function value which is k. What we have to find out? We have to find out the value of 1 by a plus 1 by b plus 4 by k. So 1 by a plus 1 by b plus 4 by k. 1 by a plus 1 by b is clearly minus 4. 4 by k is minus 4. So minus 4 minus 1, which is minus 5. So this is my final answer. Option number A is correct. Clear? So I hope till now you have got everything. There should be no doubt. If it is there, you can ask doubts. Okay. So we will wrap up this class. I hope you have some you have got some knowledge behind uh, continuity and differentiability. Okay, you can also revise some of the basic concept which we could not cover in this class, which is condition of differentiability. Okay, differentiability means LHD should be is equals to RHD. Simple. If this is true, then we can say at that point the function is differentiable. Okay, and we know these values, basic values. Then there is also a shortcut method. If a function is defined, then we can directly differentiate it and finding the LHD and RHD values. We have already done that. Okay, based on this, there is one question. You can try this one. Okay, then properties. This is major important part we should discuss. Okay, so actually the class is about to end. So you can just revise these concept. Continue for continuous function. What are the properties? If there are multiple functions, let's say f, g, h, and something something, and if all functions are continuous, then what will be the in case of fx plus gx or fx minus gx, the product of the functions and the division of the functions, they all be continuous at that point also. If both functions, if let's say we have taken two functions, both are continuous at x is equals to a, then this is very easily remember concept. So we can either we can add or subtract or multiply or divide the function, the complete function will also be continuous at that point. Okay, now the second case is if one function is continuous and another is discontinuous as some point x is equals to a, then the operation is again either addition or subtraction will also be discontinuous, because if anyone is discontinuous, then plus or minus with that function is again discontinuous. Okay, this can easily be remembered. But for the second case, the product may be or may not be continuous. Okay, this we have to remember it. Okay, so what we have to do, we have to check here. Here we have to check if one function, if in the question, if one function is differentiable at some point, and at the same point another function is, sorry, one function is continuous and another function is not continuous at the same point, then we have to check whether the product is continuous or not. But we can definitely sure about it that the sum or the subtraction of those two functions discontinuous. Okay, now in the third case, if both the functions are discontinuous at some point, then we cannot say which function in case of plus or minus is continuous, but we can definitely say one of the function will be continuous, whether it can be f plus g or it can be f minus g. If this is continuous, then this will not be and vice versa. Okay, means if this is continuous, then this will not be continuous. Okay, and but we have to check in this case f into gx, this may be continuous or may not be continuous. Okay, so also here we have to check here also which function is continuous, either f plus g or f minus g. Clear? So we have to check any one. If f plus g is continuous, then clearly f minus g will not be continuous. And the same case lies for differentiability also. Okay, based on this, there is one homework question. You can try this. Okay, so with this, just I hope you can try these questions, and these are very easy questions. And with that, we'll wrap up this class. Hope you do very well in the next mock test. Okay, all the best for your exam. Till then, bye.